Okay, for this screencast, we're going to do something called numerical, I guess I have it right up there, numerical integration. So basically, let's say we have a time variable, and I'm going to do len space 0 to, say, 10, 100 points. Actually, let's do my favorite one. So let's solve for pi. Solve for pi. So if I say x goes from minus 1, 0.1 to 1, and I'm going to say this is x plot, and then y plot is, and I'm going to make this a function, numerical integration, and then that way I can make my function y equals f of x, and I'm going to say y equals square root of 1 minus x dot hat squared, and then so y plot is just f of x plot, and then I can plot, I'm going to do a figure, I'm going to plot x plot, comma y plot. Okay, hit F5. Alright, and there we go. So there's my function there. I'm going to add a couple more data points so it's smooth. So there's my function there, right? So if I use, say, a Riemann sum, I'm going to say IR is 0, and then I'm going to say for IDX equals, or actually I'm just going to do this. I'm going to say x goes from minus 1 dx to 1, and dx I'm going to say is 0.2 for now, make it simple. And then your Riemann sum is this IR plus, and it's the value of the function at x, so f of x times dx, and that's it. And then we hit the value estimate of pi is IR times 2. So if I put this over here, I'm going to do a close all, and I'm going to put this over here. I'm going to hit F5. There's my estimate of pi. It's 3.0370. So it's not very good. So if I make this, say, 0.1, now it's 3.1045, and I make it 0.01, now it's 3.14. So we're getting closer and closer. So one thing that I like to do to make this more visually appealing is I actually like to do, I think it's called a rectangle, help rectangle. And basically, you do rectangle, position, and then you do the x-coordinate, which is x, the y-coordinate, which is f of x, the width, which is dx, and the height, which is f of x. Oh, no, sorry, the y-coordinate, it's the y-coordinate of the left square. And then I'm going to do a pause, or I'm going to, a draw now, and then a pause. And then what happens is let's see, width and height must be greater than 0. Interesting. Okay, so I'm going to say if f of x is greater than 0, plot a rectangle. Okay, so now what's going to happen is every time I hit go, it's going to, there you go, plot a rectangle. So essentially what's happening is it's integrating all of these rectangles, right? So it's underestimating over here, it's overestimating over here, and if we make our dx smaller, say 0.001, and let's see, numerical integration, bring over the plot. If I hit enter, oh man, those are really, really, really tiny rectangles. So it's really, really hard to see these, right? So you can see that, like, Riemann sum is not doing that great. So the better thing to do is to, I'm going to get rid of, well, I'll just comment out this rectangle. That way it's still there. Here, I'm going to say, I'm just going to comment all of this out. What is it there? Okay, cool. So then what I'm going to do is I'm going to instead say use Trapezoidal Rule, and I'm going to say IT equals 0, dx equals 0.1, and I'm going to say for x equals -1 dx to 1, same thing, except now it's IT is IT plus, and it's now 0.5 times f of x plus f of x plus dx times dx. And that's the area of a trapezoid. So I hit F5 here. My estimate of pi is IT times 2. And so there, oh, I got a negated. Oh, okay, so the problem is that I went over, so I need to do 1 minus dx, and that way I don't overestimate. So yeah, so I have a little bit that shoots over. You could do dx plus 1e minus 20 or something like that, and that way you don't, you could say 2 times dx. There we go. All right. So now we're good to go. So if I, and actually let's do for comparison, let's put dx up here. Let's not plot this stuff here. And then let's look at the estimate of pi. So it looks like for right now, Riemann sum is doing better. And I think that's because of this minus dx here. So looks like Riemann sum and trapezoidal rule are doing the same. Let's see. Let's pause it. Right. So the reason why these are the same for Riemann sum is because of the rectangles. So like you underestimate on this side, but then you overestimate on this side. So the error in Riemann sums cancel out. Then that's because this is a symmetric dome. If it wasn't like that, let's say we did this and we actually multiplied by 4, and then instead of integrating to 0, we actually integrated to 0. And then again, same thing, we integrated to 0 minus dx, and then again we multiplied by 4. We should see, yeah, see here now, the Riemann sum is 3.16, but the, and here let's do estimate pi, Riemann, and then estimate pi, trapezoidal. And so you'll see the trapezoidal rule is more accurate, and we can see that here. See, Riemann sum is doing really bad, 3.3 versus 3.1. So there we go. So that's really why. It's because of that symmetric dome. So the last thing I want to do just for kicks is, I think it's called help patch. Let's see, patch does 2D polygon, x, y. X and Y are the matrices. So basically what I want to do is I want to do patch, X trapezoid, comma Y trapezoid. So a trapezoid needs 4 sides. So the X coordinates are X plus dx, and then X plus dx again, and then X. And then Y trapezoid is 0, 0, f of x plus dx, f of x. And I think if we throw in a pause and a draw now, what we should be able to do is see a, let's see, not enough input arguments. Let's see, what was the other input argument? C. Oh, it's like, do I need a color? So I guess we'll do red. Is that okay? That work? Yeah, that works. Okay, so there's my first trapezoid, there's my second trapezoid, and I just keep adding trapezoids as I go, and then I stop halfway and multiply by 4. So if I make dx like, 0.5, and I'm just going to go all the way to 1 just so we can see for effect. So now we're going to have, that trapezoid, all of those different trapezoids, which is, I think it's pretty cool. If we do, say, a dx of 0.1, and we run it again, now we've just got 2 trapezoids, and we have a lot of error in there. But, like I said, if you make it like 0.01, then you get a ton of trapezoids, and they take forever to integrate, but, you really match the curve pretty well. And there you go. So there's Riemann sum and trapezoidal rule. Good luck.